Good morning, everyone. This is going to be a module on an IAN approach to 17 right at Orlando International Airport. At this point, we are in this present position. We're on a vector to the inbound course. What I'm going to do from this position, go ahead and fly the approach and explain some of the things I'm doing. I may pause it at certain points to clarify items. But the one thing that I want to point out at this time is that the approach that we're going to conduct is important that you do not have an ILS frequency, and there is no ILS frequency that is active in the nav head because we want the approach system to operate via the RNAV system. Now, another thing that I want to point out here that I have the legs over here in this depiction here, but what I'm going to do is take us to the descent page, because on this approach, this information here, flight path angle, vertical bearing, vertical speed, and the deviation are important for us to monitor during this approach. And I want you to notice at this time, we're at 5,000 feet, and we're going to be cleared to cross Elan at 170 knots at 3,000 feet. And so that will be what we're going to be cleared from this position. But notice right now that what the system is doing is reading Elan as the active waypoint. Now, let me just explain a little bit about this information here, because this is important, and this is where I think there's not a lot that you get in training, at least the places I've been. And this has to be something that you'd learn for a lot of good reasons for arrival and for approaches. Now, I want to explain again here what this information is giving us at this point. The active waypoint is Elan. And from this position, at this ground speed, this is telling us, this vertical bearing is telling us that the vector of the aircraft has to be in a 1.1 total vector, essentially, which is translated to about 500 feet per minute vertical speed to get to that waypoint at that altitude of 3,000 feet. It has nothing to do with speed. This is telling us just what the computer is telling us, that we must be in a descent at that angle. Now, flight path angle is the angle of the airplane at the present point. We're in level flight. So this is essentially a level flight vector that the aircraft is currently on. But when we start this approach, and we're going to be looking to have a vertical bearing that we either on our own or the system in VNAV is going to allow for that descent. So in this case here, what we're going to do is do this via the mode control panel. So what we're going to do is operate outside of the VNAV, LNAV operation out here as we vector into the approach. So with that, we'll go ahead and get started and continue this presentation. So ATC gives us some direction to descend to 3,000 feet. So we're going to go up here to the altitude knob, look at the altitude above the altitude tape, and set 3,000 feet. And then what I'm going to do is select level change. I see level change 3,000 feet. And I think an appropriate call, appropriate awareness is CMCP speed, which is at 220 knots to 3,000 feet. So now the power's coming back. We're back here at idle. And in this case here, notice what's happening. This is a good flight path angle of the aircraft versus a vertical bearing. So we know, and even by that altitude arc that we see here, that we are going to arrive at 3,000 feet prior to Elan. So we're looking good here, even at this speed. This is an important thing to monitor during the approach as well, this altitude arc, which we've talked about in the past. Now, what they're going to do is slow us to 190 knots. So we'll acknowledge 190 knots. We're going to set the speed here and here after we get on the appropriate mode control panel speed knob. So we set 190 knots, and I'm going to go to 1 degree of flaps, even though we're at a clean speed, because that may help us get down a little bit. Now notice what's happening to this altitude arc. It's moved out here. So now it's telling us that, we're not going to be at that altitude. Now, here's where a variable speed brake will work for you. And I can see here flight path angle and vertical bearing. I'm not going to make it. So what I'm going to do is use a full speed brake here. But in your world, because it's hard for me in the simulator to do this, I have extended the full speed brake. You can use a variable speed brake to match flight path angle and vertical bearing. I'm going to bring the speed brake back up here now and see if we can solve this from this point on. And notice this is telling us we're easily going to make 3,000 feet prior, and we're on a good vector now. Now here, what I'm going to do, again, scaling is very important. They give us a turn to a heading of 150. I'm going to set it on my nav display, and we're cleared for the approach. So at this point, what we're going to do is, once we roll out on the heading, we're going to select approach. I see that I have selected approach. I've got FAC and glide path armed. Final approach course is armed, glide path is armed. Now, this is where this information is going to become really important here as we continue this approach. Looking good, looking good. So now to comply what they previously had set is to cross a lane at 3,000 feet, 170 knots. So I'm going to go to 5 degrees of flaps and slow to 170 knots. Now notice as we're getting close here on the approach, FAC should change to a green FAC. There we are, green FAC, single channel, okay? So we're looking good. Go ahead and take your heading and dress it up to the inbound course. No sloppy headings here. Notice that we've got a glide path now that is alive, and we're looking good. Look, monitor your descent page. Notice what happens when we get a glide path capture. Goes green, and now what we're going to do is set, we get it here, we're going to set our final approach altitude at 1,600 feet for now. Okay, we'll go back to that descent page. You can see you'll be pretty busy here if you're monitoring this the way that you should. Notice right now that the green arc is right there at MNCO for 1,600 feet. So all looks good. So now what I'm going to do is put the landing gear down. We're going to go to flaps 15, set the bug for 15. And as I'm 1 mile from the final approach fix, we'll go to final flaps of 30 degrees and set ref or target, whatever your airline has you set. So we're crossing here at 1,500 feet. Now, here's where we can go ahead and set a missed approach altitude. We're approaching MNCO at 1,600 feet, good altitude. We're slowing. Now, airlines are going to have a certain procedure for you for setting missed approach on this kind of approach, but generally, once you're 300 feet below, you can go ahead and set missed approach altitude. So I'm setting 3,000 feet here. We'll continue on the approach with your appropriate calls. We can see the runway coming up. We've got a FAC capture, glide path capture, and notice here, flight path angle of the aircraft and vertical bearing are pretty much coinciding. We're just slightly high according to the vertical deviation. We've got a vertical speed of 770 feet per minute. We're 750 here. Can't get much better than this. So this is what these IAN approaches are great for putting consistency in how your procedure would be vis-a an ILS. So obviously your airline would have certain calls along during this approach that you can incorporate, but you can see that this is an excellent means of being able to fly any kind of approach. RNAV coming up on 100 feet above what we have set for minimums here. And notice, what we've talked about here before. I'm freezing it at this point. Notice what we've talked about before. Once you've picked up the VASIs and you see in this case here we're high, which is a simulator problem more so than is a real world situation, I can go ahead and adjust my vertical speed with control, cross-check it thoroughly as you're making this increased rate of descent to get down to an appropriate VASI indication for landing in the touchdown zone. And again, gang, I want to emphasize the touchdown zone is 1,000 to 1,500 feet. This is what we're looking for to be down on the runway. Okay, that does it for this lesson. Hope it was helpful on using IAN approach. Boy, it's a very efficient way to fly any kind of approach, not any kind of non-precision approach. I'll tell you, if you're ever forced in these days to fly localizer only approach and you fly an IAN, it's awesome. The other thing that I want to point out here too, for localizer approaches, and I'm going to make a module on this. This information over here makes a localizer approach where we've used different kinds of rates of descents to get down to minimums. You can fly a localizer only approach, very much like we just flew this approach in IAN, using this information to be your vertical. You're going to have a steady rate of descent through that final approach segment. I look forward to making one of those modules for you, because that is a great way to be able to fly any kind of localizer approach where you're using this information on the descent page with flight path angle, vertical bearing, and vertical speed. Okay, gang, that's it. Hey, good flying. Bye-bye.